let's take a look at how scale factors affect the volume of a similar shape. And so now we're going to be moving on from our 2D shapes into our 3D shapes and how it affects the volume of a 3D shape. So I have a couple formulas down on this side here, and you can take a look at them in the notes, in the completed notes, because you can't see them all here. It's just a couple volume formulas. Again, if I give you any volume formula, you don't have to worry. Or sorry, if I ask you to find a volume, I usually won't be using a formula. It's usually going to be based on kind of similar shapes. These are taken from a textbook that I've used and normally I've used in the past, but we don't have a textbook, so that's why I still have this in the notes. Need to adjust that a little bit. So the first thing we want to do is determine the volume of a cube that has a side length of 2. And so I'm just going to draw out a little cube. Okay, so here's a cube, has a side length of 2. Here we go. So 2, 2, 2. If we want to find the volume of a cube, it's length times width times height, which is the same thing as 2 cubed. Okay, 2 times 2 times 2. And this is the volume of 8, what do we got, centimeters cubed. Forgot the centimeters part in there. Look at that, getting a little lazy here. Okay, so we got 2 centimeters cubed. It's a total of 8 centimeters cubed. That's the volume of our this cube right here. Now let's say we're going to double our side lengths. So here we're going to draw out. I'm going to draw out a bit of a bigger cube here. See if I can do a bit of a better job. It's tough doing it going freehand. But now we have sides of 4 centimeters long, and instead of writing out 4, I'm just going to, they're all exactly the same. Our volume formula is the same thing, but now it's going to be 4 centimeters cubed. And if we multiply that together, we're going to get 64 centimeters cubed to be our total volume. Now, how much bigger is this volume? Now remember, we've doubled it, okay? So we have, we're going to put this in here, k is equal to 2. We have doubled the lengths of our sides, and that's important. Remember that a k is equal to 2, so we've doubled it. How does it change the volume? If we double the side lengths, how does we change the volume? Now we have 3 dimensions that we're changing. We're changing the length, the width, and the height. So we have to change 3 dimensions by 2, or 2 cubed. So this, okay, so if we want to try to find that, we want to try to find what is k, what is, I'm just going to leave that out here yet. We'll get to the k cubed shortly. So if we take our scale model volume divided by our actual volume, this gives us a total of 8 times bigger volume. Okay, so the volume is 8 times bigger. Okay, if we double the side lengths, it's 8 times. Okay, which is in fact k cubed. Okay, this is, and I'm just going to put this in right here. This is k cubed, or 2 cubed. Okay, 3 dimensions, we have to cube our scale factor because we are changing every single dimension by 2. Okay, and this is the way it works for everything. If we want to make it 1.5 times bigger, it's going to be 1.5 cubed is going to be the volume size difference. Okay, so if we just change it by a small aspect like that, okay, so just double the side lengths, it actually makes it 8 times bigger in volume. Okay, it makes it 8 times bigger in volume. It has a capacity that's 8 times bigger. And here again is our formula that we've looked at in the past with both dimensions and with area, but now with volume. And I'm going to do it in kind of acronym here, a little bit short form here. So scale volume is equal to the actual volume times by our scale factor cubed, or k cubed. And so if we want to find out what our scale volume is, we have to multiply by our scale factor cubed. And remember, our scale factor always goes back to the dimensions. Okay, how are the dimensions changing? We'll write out the other ones here. If we want to find out the actual volume, we use scale volume divided by k cubed. And if we want to find out our k, that is the cube root of scale volume over actual volume, or k cubed is equal to scale volume over actual volume. Remember, when we go through this here, and I just want to go through this again, this is dimension change, and this here is volume change. So if we change the dimensions by a scale factor of 2, which is what we did before, the volume will be a scale factor of 8. Okay, so we're going to have a change in dimensions by a scale factor of 2, so doubling everything, is going to make everything 8 times bigger in volume. So that's very important to remember, that this is going to be our dimension change, this is going to be our volume change. K cubed is going to be our volume change.